Hey there, Algebra 2 students. Today I want to talk to you about the unit circle because, well, lesson 9.3 is just full of information, and I'm going to break it into some pieces for us. So first I'm going to just do a video on the unit circle, and I have posted a PDF for you of a blank unit circle on the LMS. And you should go and print that out if you're able to, and fill it in with us. It will be a tremendous reference for you. The unit circle. Let's talk about the unit circle. The unit circle is a circle that is centered at the origin, 0, 0. It has a radius of 1, and any point x, y on the unit circle can be found by using the cosine of theta, sine of theta, right? And so this point right here, 0 degrees, is the point 1, 0, right? And so the cosine of 0 is 1, and the sine of 0 is 0. If we consider the point up here at the top of the circle, right, that's 90 degrees, or pi over 2 radians, right? The coordinates at this point are 0, 1. So the cosine of 90 degrees is 0. The sine of 90 degrees is 1. Let's move over another 90 degrees around the unit circle. Right, so we're at 180 degrees or pi radians. The coordinates for this point are -1, 0, right? It's just one unit to the left of the origin. We're going to come around the circle a little bit further, 90 more degrees, right? So 180 plus 90 is 270 degrees. And that is 3 pi over 2 radians. And the coordinates for this point are 0, -1. So if you needed to find the cosine of 270 degrees, it's just 0. And the sine of 270 degrees is -1, because those are the coordinates here on the unit circle. Before we go and start filling in the rest of the unit circle, I want to note a couple things at the top of my paper. You may notice that I have drawn my two special right triangles. I have a 45, 45, 90 triangle as a reference. I have a 1, 2, square root of 3 triangle, or a 30, 60, 90 triangle here. I have written SOHCAHTOA at the top for my sine, cosine, and tangent reminder, and its corresponding CHO for the cosecant, secant, and cotangent, right? And then there's this little mnemonic device, ASTC. All students take calculus is how I remember it, right? All students take calculus. And it tells me which trig functions are positive in the corresponding quadrants, right? So all trig functions are positive in the first quadrant, all of them. S reminds me that sine is positive, also cosecant would be positive, but the other ones are all negative. T stands for tangent. Tangent is positive, cotangent is positive, but sine, cosine, and the cosecant and secant are negative. So just tangent and cotangent are positive there. And the C here stands for cosine. Cosine is positive in the fourth quadrant, but sine and tangent are not, and so therefore cotangent and cosecant are not positive either. So let's take a look at filling in the rest of this first quadrant here. I'm going to use these special right triangles, the other angles. So we would have 30 degrees, 45 degrees, and 60 degrees. These are all front angles that can be found in our special right triangles, right? So 30 degrees in radians is just pi over 6, right? 45 degrees is pi over 4, and 60 degrees is pi over 3 radians. Okay, remember that as we are looking for the coordinates here, we're looking for cosine of the angle and then sine of the angle. So what's the cosine of 30 degrees? Cosine of 30 degrees, adjacent over hypotenuse, or square root of 3 over 2, right? Square root of 3 over 2. And for the sine of pi over 6, or the sine of 30 degrees, is opposite over hypotenuse, which is 1/2. And so we'll put that in there, 1/2. Let's consider pi over 4 now. Pi over 4, or 45 degrees, we'll go over here to our 45, 45, 90 triangle. The cosine of 45 degrees is adjacent over hypotenuse, so 1 over the square root of 2. We don't like writing fractions with the square root of 2 in the denominator, or any square root for that matter in the denominator, so we want to rationalize that. And 1 over the square root of 2 becomes the square root of 2 over 2. Okay. Now, what about the sine of 45 degrees? The sine of 45 is opposite over hypotenuse, which is also 1 over the square root of 2, which means when we rationalize it, it will also become the square root of 2 over 2. All right, how about pi over 3, or 60 degrees? 60 degrees, the cosine, right, is your x coordinate. So cosine is adjacent over hypotenuse, so that is 1/2. And the sine of 60 degrees is opposite over hypotenuse, so that's the square root of 3 over 2. Okay, now let's move on to quadrant 2 as we move around the unit circle. Right? Let's see. This would be 120 degrees. This is 135 degrees, and this is 150 degrees. And their corresponding radians. This would be 2 pi over 3, 3 pi over 4, and 5 pi over 6. Okay, notice that with this 120 here, the height is the same as this guy over here, the pi over 3. And so the y values are the same. It's both the square root of 3 over 2, right? The square root of 3 over 2. And the, but it's in the negative x value. It has a negative x value. It is the same distance away as the pi over 3, or the 1/2, the 60 degrees, right? But it's going to be a negative 1/2, right? And that continues for the rest of these guys, right? The 3 pi over 4 goes with the pi over 4, or the 45 degrees, right? The y value is the same. The signs are the same. It's the square root of 2 over 2. And it's still positive, but the x value, the cosine, is negative. So it would be negative square root of 2 over 2. And over here, down here, again, the y value is the same, or the sine is 1/2. And the x value is negative, so this would be negative square root of 3 over 2. Okay, I'm going to stop there and let you complete the rest of the unit circle as part of your homework. Okay, I hope you are all well. Keep keep washing your hands and stay safe. We'll see you next time.